Hello and welcome. Today's lesson is going to be about secants. A secant is a line that intersects a circle at 2 points. So in this drawing right here, we have the circle C, and we see that line J and line K are secants because they intersect the circle at 2 points, which is very different than a tangent, which is a line that intersects the circle at one and exactly 1 point. So this would be a tangent, and these two would be secants. So today we're going to talk about different theorems that have to do with secants, okay, and also tangents, okay. The first one is, let's say we have two secants, okay, or chords. And by the way, secants is when you have the line, and chords is when we just talk about the segment. So this would be a chord right there, okay, and then line J is the secant, okay. So sometimes we use those terms interchangeably, okay. But basically, this theorem that we're going to talk about is about what if we have two secants or chords that intersect inside the circle. Okay, so here's the key of this theorem is the intersections is inside the circle. And basically, when we have that intersection, we have two sets of arcs that are formed. This one right here, which goes with this other arc right here, okay? And then we also have this right here that goes with this, okay? So the theorem has to do with the arc and the angles that are formed, okay? So basically right here, the first theorem says angle 1 equals 1/2 the sum of this arc plus this arc, okay? And angle 2 is half the sum of these two arcs. Okay, so basically that's the theorem behind when you see an intersection inside the circle. Okay, so basically, let's say I have this problem right here, and I see angle x, so I can establish the relationship that angle x equals 1/2 the measure of the arc, 47, plus the measure of the arc, 116. Okay, so measure the arc HA and LK. Okay, I put that in the calculator. Okay, you can put that as it is, or you can do 47 plus 116 and then multiply by 1/2. In the calculator, you're going to get 81.5. So there you go. All right, very good. Let's see this other one right here. We have angle X. We're looking for angle X. The problem is we don't have any measurements right here nor here. So what we're going to do is we're going to call this angle right here angle Y. And once we find angle Y, we'll subtract from 180 because together X and Y is a linear pair. So first of all, what we're going to do is going to find the measure of angle Y by saying 1/2 equals the sum of 75 plus 55. And we put that in the calculator and we get 65. Now be careful, that's not our answer. Our answer is X, which is 180 minus Y, right? Because together X and Y is a linear pair. So this would be 180 minus 65, which equals to 115. So there we go right there. The answer for our problem here is X equals 15. All right, let's do another one here. This one, I do have the angle. What I don't have is the measure of the arc. So let's first set up the equation, which says this angle 128 equals 1/2 the sum of these two arcs, so X plus 154. First thing I'm going to do is send that 1/2 to the other side, so this becomes 256 equals X plus 154. Then we subtract 154 from both sides, and we get X equals 256 minus 154 is 102. So there we go. We have an answer for this problem right here. So there we go. We had three examples where we use the formulas that applies to when we have two chords. Remember, chords is when you only see the segment. Okay, two chords that intersect inside the circle. Also, we could have secants. Secants is when we're dealing with lines. Notice the arrows here. They're intersecting inside the circle, and we can apply the same theorem. Okay, so all of these examples had to do with secants of chords that intersect inside the circle. Okay, the next theorem has to do with what if I have one secant or chord and a tangent? So now I have a secant and a tangent. Remember, tangent only touches one point at the circle. So that means the point of intersection is on the circle. Remember, before was inside the circle. Okay, and we had this theorem here that applied. Now we are going to have the intersection being on the circle. So that means we're dealing with one tangent and a secant. Okay, so basically the property is the following. This angle 1 right here equals this arc that it forms, or the minor arc. So 1/2 times the minor arc. The big angle 2 is the major arc right here. So 1/2 that major arc. Okay, so basically that's the relationship we're dealing with. So when I look at this example right here, I see that 1/16, and please be very careful to read what the problem is asking. The problem is asking the measure of JLK. So the problem is asking JLK would be this major arc. So basically 1/16 equals 1/2 that major arc, which we can call it, let's say, X. And basically what we do is we move the 2 to the other side. So this would be X equals 2 times 1/16 is 232. Okay, so that's the measure of the arc that we're looking for. All right, the next problem says, find the measure of angle RQS, RQS. So we're looking for this angle right here. If QTS, QTS is 238. So this is the information that was given to us. First thing I need to do is find what is the measure of this arc, which would be 360 minus 238. We put that in the calculator, we get a measure of 122. Now that we have that, then let's call this angle X, the angle that we're looking for. So X equals 1/2 times 122 that we found, and X equals 61. So on this page, we've used the new theorems, one for when the point of intersection is on the circle, and the other one is if the point of intersection is inside the circle. So turning the page, we see a new theorem that has to do, what if I have two secants, or a secant and a tangent, or two tangents? So right here, I have two secants. Here I have a secant and a tangent. Here I have two tangents. But notice the point of intersection. The point of intersection is outside the circle. So the relationship is the following. Basically, the measure of this angle right here is 1/2 the bigger arc minus the smaller arc. Okay, same applies if I have a secant and a tangent. This angle right here is 1/2 the bigger arc minus the smaller arc. Okay, and the last one, if I have two tangents, same thing. 1/2 times the bigger arc minus the smaller arc. So the formula is always the same. 1/2 the bigger arc minus the smaller arc. It all has to do, this happens when you have the intersection being outside the circle, okay? So please remember on the previous page, we learned about what if I have the intersection inside the circle. So basically, the angle equals 1/2 the sum of the two arcs. The other theorem was about what if I have a secant and a tangent, then this angle equals 1/2 the arc that it forms. And if the intersection is outside, then the formula is 1/2 times the bigger arc minus the smaller arc. So let's look at some examples right here. So let's look at problem number 1. So I'm looking for angle 1, which is this angle right here, or angle R. So the measure of angle 1 equals the 1/2 the major arc, which is 80, minus the smaller arc, which is 40. Please remember that you can put in a calculator, make sure you put parentheses for the calculator, or you can do it in your head. 80 minus 40 is 40, times 1/2 is 20. Okay, here we have, so here we had two secants. Now I have a secant and a tangent. So again, the measure of angle 2 equals 1/2 the bigger arc, 160, minus the smaller arc, which is 80. Okay, so it'll be angle 2. 160 minus 80 is 80, times 1/2 is 40. And there we go. The next one, I have two tangents. Now notice that I have 220, but I'm missing this measurement. But that's no problem, because in this case we have the whole circle, which is 360. We subtract 220, so that means that missing arc is 140. So therefore, the measure of angle 3 equals 1/2 the bigger arc, 220, minus the smaller arc, 140. So 220 minus 140 is 80, times 1/2 is 40. And there we go. Let's go on to the next set of examples. Okay. This one, I have two secants. I have the angle outside, which is 20, equals 1/2. We're looking for the measure of this arc, which let's call it X. So we're going to start with the bigger arc minus the smaller arc. So this would be, I'm going to move that 1/2 over there. So this would be 40 equals 70 minus X. We're going to subtract 70 from both sides. 70 goes away. This becomes negative 30 equals negative X. We divide both sides by -1. That means X equals 30 degrees. Very good. Let's go on to the next one. The next one, I have two tangents. I have the angle that is outside and equals 1/2. Now, I don't have any measurements at all. So what we're going to do is, let's say we call this X. So if this is X, this will be 360 minus X. Okay, so if I write that, this would be 360 minus X, right? So this would be the big arc minus the smaller arc. So that means this would be, I'm going to move the 2 to the other side. So this would be 100. So this would be 360 minus 2x. I'm going to subtract 360 from both sides. So that gets to be negative 260 equals negative 2x. We'll divide by negative 2. So x equals 130. All right, very good. I want to give you some warnings. Let's say another student, instead of calling this x, decided to call the big one x. So therefore, this one would be 360 minus x. So the equation will look very similar, but one thing you need to be careful is this, because you're going to do 1/2. The bigger arc is x minus the smaller arc. And in this case, you must put a parenthesis inside here, okay? Because when you subtract, you're going to subtract this whole thing. So that means you need to put a parenthesis, because now this negative is going to apply to both. So I'm going to move this over here. So this would be 100. So this would be x minus 360. A negative becomes a positive x. We're going to get 100. We're going to add combined like terms. So this would be 2x minus 360. We're going to add 360 to both sides. And we get 2x equals 460 divided by 2 on both sides. So that means x equals 230. And you might say, okay, I got a different answer. Well, that's because we're calling this big arc x, and the little arc is 360 minus x. So 360 minus x, which in this case 230, would give this smaller arc 130. Okay, so which one is the best way? Is to call this guy x for this situation. If the problem had asked for you to find the bigger arc, then calling this bigger arc x would be the best strategy. Just be very careful with the negative times a negative becomes a positive, okay? Because you need to put the parenthesis there. Very good. Let's go on to the next and final example. So in this next example, we have two secants. We have this arc, and we're asked to find this angle right here. Okay, and we don't have this arc, but we also have this arc and this arc. So basically, this missing arc will be 360 minus 80 minus 100 minus 110. So that means that missing arc is 70. So basically, let's call this guy x. So x equals 1/2, the bigger arc 100 minus the 70. So 100 minus 70 is 30 times 1/2 is 15. So that missing arc, or the missing angle right there, the measure of angle V is 15. All right, so this concludes the lesson for today. Today's lesson, we talked about what happens, or the theorem that goes with two secants that cross each other inside the circle. The theorem that has to do with a secant intersecting with a tangent right on one point on the circle. And what if I have the intersection outside? Either could be two secants, a secant and a tangent, or two tangents. Okay, so there we go. I hope this video was helpful, and now you'll be able to do your assignment. Thank you very much for your time. Have a great day. Bye-bye.